What's up, people? My name is Mahardika Rahman. You can call me Adam. I am from the Universitas Gadjah Mada, majoring in geological engineering. Well, I'm a student in year 2024. Yeah, I'm in my second year right now, and this is probably my first video assignment that I uploaded to YouTube. And yeah, I don't know anything else about to add on this video, so I just create this closing as my extra minutes. Do like and comment, subscribe, everything. I will glad to hear it. I will glad to look at it. If there's any criticism, suggestion, or opinion about my video, please leave a comment. I'm glad for Pak Sugeng for take this course greatly. I hope you do enjoy it. And yeah, goodbye, people, and see you on the next video. Bye bye.
Do you know what exactly the main factor that is helping the occurrence of sedimentary deposits around the Earth's surface? Yup, that is the transportation and deposition. But what does exactly they do? Are they just going to move and changing its place to another place? Well, not just moving, but they are also affecting to its particle, depending on how transportation and deposition is occurred. This kind of understanding helps many sedimentologists or geologists to interpret on how the sedimentary particles is going to be correlated with the sedimentary deposits for how it is really occurred at the past or beginning. But what are the indications of the interpretation? Well, now let's jump into the discussion. First of all, sedimentary rocks is a rocks that has been occurred a process which is called transportation and deposition, which caused by weathering and erosion itself. Transportation in sedimentology means a movement of sediment particle or load from its origin to another place and accumulated in which called as deposition. These processes are the main elements for bringing interpretation into all of the sedimentary deposits that exist in all of the Earth's surfaces. Well, transportation could be divided into few kinds of loads. There are bed load transport, which were essentially carrying out the particle larger than a sand size. It includes a variation such as like the traction transport, the transportation that includes rolling of large or elongated grains. It could be as the sliding or impact and creep. Creep is a result of a grain being pushed to the impact. And there are the saltation, a type of bed load transport which tend to move in intermittent contact with the bed. In short terms, they are jumping through the bed, rising off at a steep angle about 45 degrees. Second one is suspended load transport, which carrying fine to medium sand-sized particles. Usually, the flow strength on this transport method is way higher than the bed load transport, resulting in more higher carried above the bed for a longer time. And the third one is a wash load, that are the most of sediment load is undergoing continuous suspension, which most of them are composed in fine clay-sized particles with a very low settling velocities. These main components is a very important term to how we can interpret the condition of the transportation load to its grain-sized particles. For instance, if we take a look for the hailstorm diagram, we can measure its type of sediment load that is carried along the flow with a specific velocity of a grain-sized particles. While grain particles are not just be correlated with its velocities and its size, but their morphologies too. Grain morphology is one of the main aspects of sediment texture, usually discussed after grain size and related aspects, such as sediment or sedimentary rock sorting. Grain morphology is classified into two approaches. According to Tucker, there are form, degree of sparsity, and the degree of roundness. And according to Pettijohn and Box, are form, degree of roundness, and surface texture. form is a proportional variation of size in length that includes the three major axes in a rock that were short, intermediate, and long. The relationship between form and the grain morphology is usually called as sphericity, which is how close the grain shape looking like a sphere. Well, this type of grain morphology can be also correlated by the particle roundness. Usually, particles below the sand-sized grain are not easily get abraded during transport. This is because the particle that has a size equal or even below the sand, it tends to have a higher sphericity and a higher roundness rather than a pebble to cobble-sized particles. This also could be related to the surface textures. Removal of all surface textural features and generation of a new features are more likely to occur than marked change in sphericity and roundness. And the surface texture is more likely to record the last cycle of sediment transport or the last depositional environment. The application of these terms are the main tools of indicators, besides just for the transportation and deposition, and for most importantly, as the indicator of the grain distribution. Grain distribution has an important role for reconstructing the depositional environments, transport history, and the stratigraphic correlation. For example, we take a look at this rock sample that is picked at the upstream section of Yogyakarta area. The rock looks very angular and very coarse. And this is the middle stream rock sample, which has more roundness than the upstream rock. And this is the downstream sample, which is the most rounded one. These three samples can represent the main grain distribution on Yogyakarta area. The upstream area predominantly has an angular form of grains, so then it could be interpreted with the transportation load, which has the bed load transportation that are carrying medium to coarse grains. And the one in the middle stream and downstream can be carried by suspended load or even wash load because of its higher velocity of energy and smaller grain. Another method that shows the grain distribution analysis is the grain size data. Grain size is a very fundamental physical property of sedimentary rocks, and as such is a useful descriptive property, because grain size affects the related derived properties of porosity and permeability. The grain size of potential reservoir rocks is one of the considerable interests of petroleum geologists and hydrologists. For example, we can take a look at this relation of sediment transport by plotting grain size data as a cumulative curve on a log probability paper. Well, this graph can explain the each of grain size data that has been accumulated through each of the sediment transport load, but this log probability paper is not widely applied because of some assumptions in this method has some criticism. It appears that after several decades of intensive research into the techniques and the significance of grain size analysis, during which the techniques for interpreting the grain size data have come to demand increasingly sophisticated statistical applications, there is a little consensus as to the reliability for environmental analysis, such as a science. Well, in conclusions, transportation and depositions are not only responsible for the movement and accumulation of sediment particles, but also they play a very crucial role in shaping the grain distribution, size, and morphology. By examining these characteristics, geologists and sedimentologists can reconstruct depositional environments, interpreting the transport histories, and establishing the stratigraphic correlations. Grain morphology, sorting, and size distribution provides valuable insights into the energy conditions, distance of transport, and the type of load that is involved, whether it is bed load, suspended load, or even a wash load. Although methods like grain size analysis continue to face limitations and debates, they remain essential tools for understanding sedimentary processes. Well, ultimately, the study of grain distributions highlight the dynamic interactions between transportation, depositions, and sediment themselves, offering a deeper perspective on Earth's geological history.